I'm Bianca Trafalus and I work for the Athens Institute for Education and Research, which is a World Association for Academics and Researchers. I'd like to welcome you to ADNER's interview series, where we interview the participants that attend our mini conference in Athens. Today I'm going to be interviewing Dr. Mathieu Sebilo, who's an assistant professor at Sorbonne University in France. Hello, welcome to Athens. How are you?
Not too bad.
So, can you give me a brief academic introduction of yourself?
Yeah, I started with biology, studying biochemistry, organic chemistry, something like that. More focused on human physiology. And after 3 years, I changed for ecology and the science of ecosystems, biology of population. After that, I did my master degree. It was focused on technical sciences, on environmental sciences. After that, I did a PhD focused on biogeochemistry. It was in the Department of Earth Sciences. And currently, I am assistant professor and I teach and study biogeosciences.
Okay, so what's your current major area of research?
Okay, my current research is to use stable isotopes to trace reactions and processes from the millimetric scale to regional scale and at different time scale. Okay, because by using isotopes you can integrate so many sources of pollution, for example, and many processes. And my focus is nitrogen cycle.
Okay, so tell us a few things about your presentation at the conference. What did you present?
It was exactly the same thing. It was to explain how helpful could be and powerful could be isotope biogeochemistry. How is it possible to trace some nitrogen processes within the soil, and basically isotopes are useful to characterize processes. And the new thing is that I mixed the use of isotopes and model, and then based on the model and the use of isotopes, I could quantify the processes and where occur the processes at the scale of the watershed.
So what were the results of your research exactly?
I explained to this morning that when you apply some nitrates on soil, for example fertilizers and atmospheric nitrates, each input have their own isotopic composition, and the nitrates measured at 1 meter depth don't reflect the mixing of the inputs, but that when you apply nitrogen on soil, there is a lot of internal nitrogen cycle which combine the sources of nitrogen, and because of a lot of processes within the soil, then you have a sort of inertia of the system. So when you apply nitrate, for example, today, you could find nitrate in the groundwater in the next century, because you can keep the nitrate in the first meters of soil, and if you work very well, you can have the same yield of crops and decrease a lot the concentration, the amount of nitrogen going to the groundwaters. It was the focus of my talk.
Okay, thank you. So how were you introduced to ADNER, and what made you attend the conference?
I just received an email, I think 3 or 4 months ago, and explaining the focus of the meeting, and I was quite interested by the session of isotope hydrology. This is my first session of isotope hydrology. Mainly, I present 2 or 3 meetings a year. It's more focused on isotope biogeochemistry or soil sciences, but not isotope hydrology. That's the reason why I decided to come here.
Okay, so since you're from France, can you tell us a few things about the higher educational system in France, and what do you think are its advantages and disadvantages?
Okay, in France we have two types of education:
Mm-hmm.
university and engineer school. Okay, it is very hard to enter in engineer school. It's easier to go to university. Everybody could go to university in France.
Mm-hmm.
But I think that the advantages of university is that after a master degrees, I think that you could become an expert on your focus on your thematic approach, and that's the reason why a lot of companies would like to have a lot of students coming from the university. At the opposite, in engineer school, to me, it is more focused on management. Okay, and management, scientific management, for example. For instance, it is not a problem, but and the problem is that when you start in engineer school, after 5 years, for example, it is really easier to find a job because you have the network of your school. It is so easy to find a job. It is more difficult for scientists coming from the university. I think this is a big challenge for the student in the university. But I think that they have a lot of knowledge, a lot of experience. It's not a school, so they have to choose their courses to build their career within the university. I think this is good experience. And I teach a special level in master, and my students are in the university 1 month and in a company 1 month. So they learn scientific background and they use it in their company, and we have a huge professional insertion, around 95% after 3 months after obtaining the diploma.
Okay, thank you very much.
You're welcome.